Hey 8th graders, today's assignment is called Is It Balanced? So lately we've been talking a lot about the law of conservation of matter and how matter cannot be created or destroyed. So when we're talking about a chemical equation, we look a lot about how many atoms of each element go in as a reactant and how many come out as a product. And due to the law of conservation of matter, those numbers have to be the same. You can't just have atoms disappear or atoms reappear. That didn't exist in the reactants. So what we're going to look at today is just whether or not these chemical equations are balanced. We're not going to quite get into how to balance them. So all you'll be doing is counting atoms today and then telling me whether or not these chemical equations follow the law of conservation of matter. So your learning targets for today: I can apply the law of conservation of matter to a chemical equation, and I can identify if a chemical equation is balanced or not. Okay, so I'm going to do the first one for you guys and just show you guys how this looks. So obviously up here we have a chemical equation for you, and you guys will notice that in front of some of these molecules you will see some coefficients. That won't always be the case. In the instance of the last compound here, we don't have a number other than the imaginary one, meaning we only have one molecule of H2, whereas these other molecules, we have two molecules of each of them. So two atoms of potassium, 2 molecules of water, and 2 molecules of potassium hydroxide. All right, so what you guys will see underneath that is this little table. On the left-hand side of this table, you'll have the reactants, and on the right side, you'll have the products. You guys will use this as kind of an accounting tool to let you guys count up how many reactants and products you guys have for each atom of each element. Okay, and then down the middle, you guys will see the different elements that you will find in these chemical equations. So in this case, we're going to find K for potassium, O for oxygen, and H for hydrogen. So you guys will be responsible for counting how many atoms of each of these 3 elements there are. Okay, so let's look at the first one, potassium. Let's go to our reactant side, and we're going to count how many atoms of potassium. So if we look at our whole left side of this arrow here, those are our reactants. And this is the only spot right here where we have potassium. Okay, and because it has a coefficient at front and no subscript, we have 2 times imaginary 1, so 2 potassium. You guys can either click in there to type or you can use your draw tool. That's up to you. And then the next one we have is oxygen. So we have oxygen right here on our reactant side. And there's an imaginary subscript of 1 right after that oxygen. But we have 2 molecules of water here, so we have 2 times 1 is 2 atoms of oxygen. Finally, hydrogen for our reactant side. We have hydrogen right here and nowhere else. Okay, we have 2 atoms that we find in 1 molecule, but in this case we have 2 molecules, so it would be writing H2O twice. So in this case we have 4 hydrogen atoms, or 2 times 4 is 4. Okay, so that takes care of our reactant side. Now let's go ahead and look to the right side of the arrow, which are our products. And we're doing the same thing there. How many potassiums do we have? So we have 2 times 1 here. It's 2 potassium atoms. Oxygen, we have oxygen just right here. So 2 times that 1 oxygen is also 2. And then finally our hydrogen is a little bit different because you guys will notice that we have hydrogen in 2 places here. So we have 2 times 1 here. So we have 2 hydrogens on this side and then another 2 hydrogens right here. So for a total of 4 hydrogens. Okay, now we look and say, all right, we have 2 potassiums on the reactant side, 2 on the product side. That abides by the law of conservation of matter. There was nothing created, nothing destroyed there. Oxygens, 2 on the reactant side, 2 on the product side. So again, that abides by the law of conservation of matter. And then finally our hydrogens, 4 and 4. So that also abides by the law of conservation of matter. So what you guys see in this is, yes, this equation is balanced. So you guys would circle or highlight yes. Okay. Other reactions you guys will be looking at today is hydrochloric acid and sodium hydroxide form salt and water. Potassium nitrate forms potassium nitrite and oxygen. We've got a fuel right here, carbon-containing fuel, combusting in the presence of oxygen to form carbon dioxide and water. And another carbon-containing fuel, combusting, same process as last time. Mercury and oxygen forming mercury oxide. Silver nitrate plus salt, or sodium chloride, however you guys want to say it, forms silver chloride and sodium nitrate. Magnesium metal plus oxygen gas come together to form magnesium oxide. Aluminum oxide decomposes to form aluminum and oxygen. Phosphorus plus oxygen form phosphorus for oxygen, P4O6. And we've got nitrogen plus hydrogen forming ammonia. Iron and water forming Fe3O4 plus H2, which is iron 4 oxide. And sodium sulfate plus calcium chloride reacts to form calcium sulfate plus sodium chloride, which is table salt. And last but not least, we've got the decomposition of hydrogen peroxide, which you guys will see happen in class next week. So this is H2O2, which is hydrogen peroxide, reacts to form water and oxygen. Okay, so you guys will go through, you guys will fill out the tables for each of these. Tell me how many reactants there are, how many products there are, or how many atoms of each of those. And then look at those numbers in the table and encircle whether it is balanced or not balanced. Remember, if you guys have the same numbers on both sides, it is balanced. But if, for instance, you guys had maybe one silver over here, but two silver atoms over here, that would be not balanced. So make sure you guys fill out the whole table first and then answer yes or no. Okay, if you guys have any questions, let me know. If not, I hope you guys are having a great day, and I will talk to you soon.